Hello friends, once again I'm going to discuss another question of indefinite integration by the method of substitution. And till now you're very familiar with the method of substitution. How do we integrate a function, whether it's finite or indefinite? Here again we need to always in substitution method we replace our variable these all independent variables with new function, and then later we do some process and then we replace with the original one at last. So let me suppose again let new term t equals to, you can suppose x as well as you can suppose x plus 2, but I'm going to suppose x plus 2 because if I'll suppose this, then I can easily remove this 2 while differentiating. Alright, that's my trick. Always try to suppose something that is inside the root, or something with that is added with some constant, because derivative of constant is 0, so it is better to remove. We need to get always shorter and shorter values. Okay, so I'm just gonna suppose x plus 2, and now I'm just going to differentiate both side with respect to x, and I will get derivative of x, that's 1 simply. And here I can say that dt is equals to dx, and based on this result I can say that my integral is getting a new phase, that is first dx is getting converted with dt. Alright, I'm writing here dt, but you need to start with here, and x from here I can say that x is, this 2 will go in this side, it will be t minus 2. So I'm first writing x, that is t minus 2, and then let's discuss about this x plus 2. X plus 2 I have supposed as t, so it's t, and root, that means the power is raised as half, and overall finalizing the answer, that's t is being multiplied by t to the power half, so it's t to the power half, and again this 2 is multiplied by t to the power half, and then dt. Further, let's go. I'm just separating now term, so t to the power 1 and this one, it will be added, so it will be t to the power 1 plus 1 by 2 dt minus, again 2 is coefficient constant, it will come outside, and t to the power 1 by 2 times dt. And further now integration of t to the power half, 1 plus half, that is 3 by 2 dt minus 2. I can use the formula directly, right? It will be t to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus constant 1. Okay, right. I used a simple integration formula, power rule of integration. All right, that the simple, you know that very well. If not, then comment, I'll write it back. All right, so t to the power 3 by 2 plus 1 here also, the simple integration, and again constant 2, I have written 1 already, minus 2, and now t to the power half plus 1, that is 3 by 2, and again here it is half plus 1, that is 3 by 2, so that 2 will multiply over, writing 3 over 2 here and writing that 2 directly here, that same thing. Okay, and this 2 will multiply c1, so it's minus plus, that doesn't matter, twice of c1. Further, again here 3 by 2 plus 1, it's gonna be 2 plus 1, 5 by 2. Alright, so 2 will be up and 5 will be at the down, t to the power again 5 over 2. Alright, minus 2 times 2, that is 4 over 3, t to the power 3 by 2, and c2 minus twice of c1, all by 3 constant. So in these circles place for these two kids, I can overall write it's some constant, and that's my integration. And now the final step is left, replacing this, not the sixth, yeah, it's a sixth step by the way, t replacing, I'm going to substitute the value of t, that is x plus 2. So our final answer is 2 by 5 x plus 2 to the power 5 by 2 minus 4 by 3, t is x plus 2, x plus 2 to the power 3 by 2 and plus some constant. That's it. This is the solution of our question, and we solve this indefinite integration by the method of substitution. The same process you need to follow everywhere.